Hello folks, we are once again back with the next exercise, that is exercise 7.4. But before we start that exercise, we need to know some formulae. So that should be added to the database. So it's on the basis of these formulae that we are going to do the upcoming exercise. These are called as some special formulae. Okay, so let's just go through these formulae, and that's how we are going to take up the exercise. We are going to take the exercise 7.4, and for that we require these formulae. First one, integral of dx over x squared plus a squared is going to be log of x squared plus a squared. Okay, let's start with x squared minus a squared. X squared minus a squared is 1 over 2a log x minus a over x plus a plus c, log modulus of course, and then the integral of dx over a squared minus x squared is same way 1 over 2a log of a plus x over a, log modulus of course, log modulus a plus x over a minus x plus c. Then you have the integral dx of x squared plus a squared, and this is going to be tan inverse. So this is going to be 1 over a tan inverse of x over a plus c. So also we have the same formula with the root. So dx a root of maybe x squared minus a squared. So that is going to be log modulus x plus root of x squared minus a squared plus c. Similarly, you have integral of dx over root of x squared plus a squared, and that is going to be log modulus x plus root of x squared plus a squared plus c. So also you have integral of dx over root of a squared minus x squared, and that is going to be simple sine inverse of x over a plus c. So that's all. So these are the formulae on the basis of which the exercise that we are going to do is, once you know this formula, the exercise is very simple till the 10th question. After the 10th question, there is this concept of completing squares coming. So there we have to brush up our old concepts and then do it. So that's about it. So let's quickly move on to the exercise 7.4, and the very first question there, which says that you have to find out the integral of 3x squared and x raised to 6 plus 1. Now it's very evident from the very question, it's very evident because the numerator has got 3x squared, that there is some substitution like x cube coming. That's how the 3x squared is there. So we can write this as 3x squared dx. Instead of x raised to 6, we can write it as x cubed the whole squared plus 1 squared. 1 is 1 squared, whatever. 1 raised to anything is 1 only. So you can write it the way you want. Now why we wrote it like this is that we are going to call u as x cube. So we know that derivative du over dx is 3x squared, and therefore it is 3x squared dx. Directly you will get the substitution. So your I now becomes, because we don't want to work in higher powers, so we are substituting this u so that you can work in lower powers. So therefore you have the integral du. This entire thing has become du. X cube is u, so it is u squared plus 1 squared now. That's okay. Now this is good. Why? Because you know the integral x squared dx over x squared plus a squared, this one. So you can use it. It is given as 1 over a tan inverse of x over a plus c. So let's put that. So it is 1 over a. A for us is 1. So 1 over 1. This is a, and that's 1. Tan inverse of x over a plus c. So that is just tan inverse of u. All those ones, it's not significant. So u for us is x cube. So it is tan inverse of x cube plus c. So simple. Just with that substitution, the work is very simple. We bring back to any one of these types and get our work done. So quickly, since we have got this, we can move to the next problem, that is integral of dx over root of 1 plus 4x squared, which you can also write it as See, anyhow, apparently as it is given to us, we may not know how to substitute. But if you get it into any one of these forms, then it's easy to get the integral formula. You just apply the formula, get the answer. So you have to get it into that form. That is our task. Once you get it into that form, then it's really child's play. So this also, one I have told you, it's like universal. You can put it the way you want. So this 1, we can call it as 1 squared. And 4x squared, you can always call it as 2x the whole square. 2x times 2x is 4x squared. Now why we do that is because an integral dx over a squared plus x squared, it. Root of a squared plus x squared is actually log modulus x, a squared, x plus root of a squared plus x squared plus c. So this is the formula that you're going to use. Log, and then so directly we can apply. So you are going to get log modulus x, but for us is 2x, plus, see, this is the given term. So either you write it like this or you write it in given terms, whatever way you want, that is your convenience. So this is going to be 1 plus 4x squared plus c, but only thing you have to be careful here is that it's not x, it's 2x. So you have to contribute to the integral coefficient, and always we have understood the differential coefficient will get multiplied, but integral coefficient will get divided. So that we have to be careful. Since there is this coefficient 2 there, just divide it. That's all, and that's your answer. So what we did is we got it into that form. That's it. That's how it is going to be. Third one is also like that, where it is of that form, but then that making it into that category is very important. So here it is root of 2 minus x the whole squared plus 1. Now always I have told you that a linear function will always behave like x. No matter where you get the linear function, how the x is behaving, it will behave like that. So here also, since it's a linear raised to 2, so it will behave exactly the way how x is behaving. So that should not be a concern for us. But if you want, you can substitute u. That also you can do. So maybe we can, as beginners, we can substitute. And then later on, when you do a number of problems, you'll realize that there's no need for substituting because it's behaving exactly like u, like x. So, but then as beginners, I think, it's worth substituting. Let u be 2 minus x. Here also we could have done that. Okay, u equal to 2x, we could have substituted, but it's okay. So your du over dx is 2, no derivative. Derivative of minus x is minus 1. The dx will go, so minus 1 dx. So let's get the I now. I is going to be minus du, and then this is u squared. 1 can be written as 1 squared. So what category it is into? Integral of dx over root of x squared plus a squared. So that we know is log modulus x plus root of x squared plus a squared plus c. So let's substitute. This is just log modulus u, negative is there, u plus that root, u squared plus 1 squared plus c. Now bring it back. Log u for us is 2 minus x plus this is what they intend. So anyhow, you can write whatever you want. So it's 2 minus x the whole squared plus 1 plus c. That's it. So that's all for this video, where we have taken up the 3 problems and we realize that actually there is not much work there. Just get it into the desired form and then apply the required formula. So I think with more problems, let's meet in the next video. That will be our next lot. Thank you.